Hello guys, welcome to the mathematics lesson with me, your teacher, Mr. Masumba, the owner of the DMS Online School YouTube channel and Facebook page. So in today's lesson, we are going to continue from where we ended in the previous lesson because we started looking at this new topic in mathematics, which is called matrices. So we did two lessons, and then in today's lesson, which is lesson number 3, we want to look at how we were supposed to answer the questions which I gave you in the previous lesson. So to begin with, we have question number 1 here. This is question number 1, which is if P is this matrix 2061 and Q is this matrix A01B, find part 1 or Roman numeral number 1 PQ, then 2 the value of A and B, value of A and B, given that PQ is equal to P minus Q. Then in part 3 we need to find the determinant of P. So let's go straight into answering this one here. So go by saying solutions. So we want to answer number 1. Number 1, we are told we should find PQ. So when they say we find PQ, it means we are multiplying P times Q, meaning matrix P multiplied by matrix Q. So when we say PQ then is equal to, where this P, we'll put this matrix, which is 2, okay, then 0, then 6, then 1, like that, okay. Then we'll say times. Then where there's Q, we'll put that matrix, which is A, like that, then 0, then 1, then B, like that, okay? Okay, I hope you have followed very well. Then next, we should now multiply, okay? So since the number of columns in this matrix is equal to the number of rows in the second matrix, then these two matrices can be multiplied, okay? So what we can do here is by just doing like this. We'll say 2 times A, so we say 2 times A, then plus, then we say 0 times 1, 0 times 1. Then we'll say 2 times 0, so 2 times 0, plus again, then we'll say 0 times B, 0 times this B here, okay? Then we'll say 6 times M, so say 6 times M, then plus we'll say 1 times 1, 1 times 1. Then we'll say 6 times 0, 6 times 0, plus, then we'll say 1 times B, 1 times B. Then we can close like that, okay? Then we'll say equals, then we'll say 2 times A, it will be A, okay? Then plus, sorry, it will be 2N. So 2 times A, it will be 2N, so put 2A, then plus, then 0 times 1, it will be 0. Then we'll say 2 times 0, it will be 0, then plus, then 0 times B, it will be 0. Then 6 times A, it will be 6A, then plus, then we'll say 1 times 1, it will be 1. Then 0 times 0, it will be 0, plus, then 1 times B, it will be B, okay? You put like that. Then you say now, like 2A plus 0, it will just give us 2A. Then 0 plus 0, it will just give us 0. Then 6, yeah, 6A plus 1, these cannot be added because they are not like terms. So it will just be 6A plus 1, okay? Then 0 plus B, it will just be B like that is that. So this times that gave us this times that gave us that. So meaning this will be our answer. So you can say therefore P Q is this one. So you can even underline like that. So this is 2A, 0, 6, 6A plus 1. Okay. And let's go to part 2, where we need to find the value of A and B. Given that PQ is equal to P minus C Q. So we have PQ is equal to P minus C Q. So we need now to find the value of A and B. Given this, it will be simple. So what we are going to do is to substitute. We know PQ is this one here. PQ is this matrix here. So put 2M, 2M, then 0, then 6 plus 6, 6A plus 1, then B here. Then we'll close, then we'll put this equal sign. Then P is this matrix here, 2, 0, 6, 1. So say 2, 0, then 6, 1. Okay. Then we are going to close. Then we'll put minus. Then in Q it is this one, A0. So A0, then 1B. So we'll also close. Then once we do that, then what we should know is that these two matrices are subtracting. So we have to subtract them according to what we learned about subtracting matrices. Because these matrices have the same order, so they can be subtracted. So we say, okay, we'll have 2M, then 0, then 6A plus 1, then B, and we'll put like this is equal to, then also this 2 minus A. So say 2 minus A, then we'll say 0 minus 0, 0 minus 0. Then we'll say 6 minus 1, okay? 6 minus 1, we'll go direct. 6 minus 1, it is 5. So here, let's put direct 5. Then 1 minus B, it will be 1 minus B, like that. Now, once we do this, we have come up with one matrix on this side. On this side, we have this matrix. On this side, we have that matrix. So in mathematics, what that means is this matrix is equal to that matrix. So if the matrices, the two matrices are equal, that means also the corresponding elements are equal. It means this element here is equal to this one is equal to that one. Okay? That's what it means. So this one is equal to this one here. And this one is equal to that. This one is equal to this. And then this one is equal to that. So it will be so easy. So since we want A, so we will equate these elements. So we get like 2M, we'll put equals this one, 2 minus A, 2 minus A. Because each and this one is equal to that, this one is equal to that, this one is equal to that. But since we want A, we can put this 2A minus 2 is equal to 2 minus A. Now, when we do like this, realize that we have an equation. So in this equation, we need to solve for the unknown. In this case, the unknown is A. So for us to be able to do that, we need to collect like terms. By like terms, we mean the terms that are similar. Like this is a term which has a variable, and this is a variable. So these are similar, and this is just a number. So it is not similar to these guys. So like terms, or rather variables, should be on the left side of the equal sign, and constants or numbers should be on the right side of the equal sign. So to do that, we can say, okay, 2a, this one will be collected together with the minus. It will cross to find the other variable 2a. So once this crosses, it becomes positive a. Then you say equals, this side you remain with 2. Then what you are going to do, you say 2a plus a, you get 3a, which is going to be equal to 2. Now what you're interested in, remember, is to know the value of a and not 3. So you have to get rid of 3 by dividing this term by 3. And once we divide by 3 on this side, also do the same on the other side by dividing by 3. So that now 3 into 3 can go, you remain with a, which is going to be a is equal to now 2 over 3. So this will be our answer. So therefore, a is equal to 2 over 3. We have found it. Then now we need to know b. So to know b, we can either get this is equal to this or this is equal to that. So for me, I see this one is simple. So I'll get this is equal to that. So same b is equal to 1 minus b. And again, this one becomes a mathematical equation in which we have these as variables and then we have 1 as a constant. So we'll also collect like terms where we have b here. Oh, sorry, that is not b, I've written f. So let's write this one. So you're saying this b will be here. Then this crosses, comes this side, it becomes positive b. Then equals, then we have 1. Then here you say b plus b, you get 2b, then equals 1. Now remember you want b not 2, so to get rid of the 2, you divide by 2. Also you do the same, this side you divide by 2, so 2 into 2 to go. So b is going to be equal to 1 over 2. So therefore, b is 1 over 2, like that. Okay? So we have found both the values of a and the value of b. So now let's move to question number 3 or part 3, which says we find the determinant of p. So the determinant of this. So let me just clear this part. So will be on 3. So we need to find the determinant of p. So remember, determinant is represented by d, e, t, which is going to be determinant of p. That's how we write it. So determinant of p now can be equal to, remember we said it is given by the product of the elements in the major diagonal, like 2 times 1, then minus the product of the elements in the minor diagonal, like 0 times 6. So you say equals, then 2 times 1 will be 2, then put minus 0 times 6, it will be 0. Then you say equals 2 minus 0, it will be 2. So you say therefore, determinant of p is equal to 2. Okay? So this is how we answer most of the questions in matrices. So let's do question number 2. So let me just clear everything and do question number 2. So question number two, we had this. So two says if um if A is equal to 2, 3, then negative 5 or negative 1, negative 1, 5, like that. Then B is equal to um, 2, 3. Okay, 2, 3. No, no, no. Like this, 2, 3, like that. Then they're saying find, so we find part 1 or Roman numeral number 1, the determinant of A, the determinant of A. Then part 2, they're saying the inverse of A. Find the inverse of A. Then part 3, find the value of AB. The value of AB. Then part 4, the transpose of matrix A. The transpose of matrix A. So this was question number 2. So let's see how we should have answered this one again. Again, these are easy questions. So we'll go for solutions. So that one, we are told to find the determinant of A. So we say the determinant of M is equal to the elements, the multiplication of the elements in the major diagonal, which is 2 times 5, minus the multiplication of elements in the minor diagonal, like 3 times, open brackets, negative 1, like that. Then you say 2 times 5, which will be 10. Then here you say negative 3 times, actually negative negative 3 times negative 1, it will be actually positive. So this one will change like positive 3. That's how it is going to be. Okay. So now it will be easy. So it will just be like 10 plus 3, which will be 13. So say, okay, therefore, the determinant of A is this answer here. Very simple. Then part 2, the inverse of A. Find the inverse of A. So we need to find the inverse of A. So remember, inverse, which is represented like A to power negative 1, is given by 1 over determinant of M. When we open brackets, we swap these values here. 5 comes here, then 2 comes here. Then we put a negative here. We multiply a negative there, so it will be negative 3. Then here we multiply a negative, it will be now positive 1. Okay? That is how we find the inverse. Then you say equals, you say 1 over, determinant of A is this we have found here, which is 13. So we just plot in 13 there. Then we'll say open brackets, we'll say 5, then negative 3, then 1, then 2, Then from there you say equals, you multiply now the value here times this. So say 1 over 13 times 5, it will be 5 over 13. Then 1 over 13 times negative 3, it will be negative 3 over 13. Then 1 over 13 times 1, it will be the same 1 over 13. Then 1 over 13 times 2, it will be 2 over 13, like that. So you say, okay, therefore, the inverse of m is equal to this. Then you can underline like that. Okay? So you see that mathematics, if you are following steps and you understand concepts, actually it is a very easy subject to pass. Okay? So let's move to part 3. Part 3, they're saying we find the value of AB. So I'm going to rub so that I remain with space here. Okay. So part 3, we are finding AB. So AB, it means we are multiplying matrix A and matrix B. So say, okay, this one is equal to, so matrix A is this one, we put 2, then 3, then negative 1, then 5, okay, like that. Then we say times, then B, it is this one, 2, and 3, okay. Now remember, the rule is for two matrices to multiply each other, the number of columns in the first matrix must be equal to the number of rows in the second matrix. So here we have how many columns? 1, 2. How many rows here? 1, 2. So these have been satisfied. So that means that these two matrices can subtract each other. So I mean multiply each other. So we can say 2 times 2, so 2 times 2 plus 3 times 3, 3 times 3. The negative 1 times 2, so negative 1 times 2 plus 5 times 3, so 5 times 3, like that. Then we'll say equals, so we'll send 2 times 2, which will be 4, plus 3 times 3, which will be 9. Then here negative 1 times 2, it will be negative 2, plus 5 times 3, which will be 15. So then we'll do like that. Then we'll say equals 4 plus 9, which will be 13. The negative 2 plus 15, which will be also 13. Okay. So therefore, we say therefore, A times B, it is giving us here 13, 13. Then we'll move to part 3, which says we find the transpose of matrix A. So part 4, or Roman numeral 4, transpose of matrix A is written as A to power T, which is going to be equal to, you change what were the rows to become the columns. So it will be like 2, negative 1. So you write 2, negative 1. Then you say 3, 5. So say 3, 5, like that. So the columns have become the rows, and the rows have become the columns. So this one was like this, night is like this one was like this, night is like that. So that is the answer here. Okay, let me see if I had to give you another question. No. So this is all. I think as far as questions in matrices are concerned, I think this is the level of questioning which is there in the exam, which you need also to to know, okay? But if you find other questions on matrices that are challenging, you are free to post the question in the group and ask, or not, either in the group, or you send it to me direct on Telegram to my inbox to say, sir, I found this question on matrix. I was unable to answer it. How can it be answered? And I can see how to help you. Thank you very much for watching. For now, bye, and see you in the next lesson.